ঠান্ডা জোরে গেছে। Good morning, students. Am I audible, visible? Write in the chat box. Nasreen, Pankaj, Samyajit. Am I audible and visible? Rajalakshmi. Hello. Okay, let's start. Today we'll start a new topic. Dear students, today I'm suffering from cold and cough. Okay, write down 3D geometry. If background that is black with the go to illness message. So three-dimension geometry, first of all, we start with the Cartesian system of three-dimension geometry. The system consists of three mutual perpendicular lines. One of the line is called x-axis, second one is called y-axis, and the third one is called z-axis. Okay, angle between x-axis and y-axis is 90 degree, y-axis and z-axis is 90 degree, z-axis and x-axis is 90 degree. Actually, just because I'm drawing in 2D plane, you see the system is like this. If you can see me, this is x-axis, x-axis, y-axis, z-axis, right? The system divides the space into three coordinate planes. One is XY plane, YZ plane, XZ plane. XY plane, YZ plane, XZ plane. This plane is XY plane. This is YZ plane. This is XZ plane. Right? And the second point is the system divides the space into 8 regions. Each region is called an octant. Okay. Then come to Cartesian coordinate of a point. Cartesian coordinate of a point. In 2D geometry, if you want to get the coordinates of a point, come in two-dimensional geometry, if P be a point, to determine the coordinates of the point P, we have to draw two perpendiculars. One of the perpendiculars is drawn from point P upon x-axis. Another perpendicular is drawn from point P to y-axis. Okay. If this length is x unit and this length is y unit, then the coordinates of point P are x, y, x, comma, y in 2D geometry. Similar is the case in 3D geometry. To get the coordinates of a point, we have to drop three perpendiculars from point P. One of the perpendiculars should be drawn from that point upon x-axis. Second perpendicular should be drawn from the point to y-axis. And third perpendicular should be drawn from the point to z-axis. Due to cold and cough, my voice is not clear, guys. So try to cooperate me today. Okay. Nasrin, am I clearly audible? Okay. So this is suppose 3D geometry. Three lines are there. One is x-axis, another one is y-axis, third one is z-axis. Okay. A point is there in the space. This is suppose point P. Okay. So if you suppose this is x-axis, this is y-axis, this is z-axis. A point is there in the space. If you want to get the coordinates of the point, you have to draw three perpendiculars from that point upon x-axis, y-axis, and z-axis. Suppose this is point P. So if you drop a perpendicular from point P upon x-axis, let this be put up the perpendicular y-axis and the z-axis. Okay. This distance, suppose this is O, origin of the system. Suppose the perpendicular drawn from the point P upon x-axis meets x at A, and perpendicular drawn from point P meets y-axis at B, and z-axis at C. Then the length OA is equal to x-coordinate of the point. Let it be alpha. Length OB is the y-coordinate of the point. Let it be beta. And this distance is gamma. Then you can say that alpha, beta, gamma are coordinates of the point. Okay. We should take the help of another figure before going to locate the coordinates of a point. You should understand the concept. This is suppose a plane. This is normal to the plane. My hand is clearly visible to you, Pankaj? My hand is clearly visible to you. Hello, Nasrin. Okay. Comedy to just see my if you consider my palm as a plane and this stylus is normal to the plane, if you draw a line on my palm anywhere in my plane, in my palm, that the stylus will be perpendicular to that line. Okay. If this is a plane, I'm drawing in 2D plane. This is a plane, this is normal to the plane. If we draw a line like this, then angle between this line and normal to the plane will be 90 degree, because we can translate the line to the feet of the normal. Angle between the line and the normal will be 90 degree. Taking this concept, we can find the coordinates of a point in two-dimensional plane, three-dimensional plane. right? Suppose this is our x-axis, this is y-axis, this is z-axis, right? Let P be a point. If we drop a perpendicular from point P upon x-axis, that will meet at this point. If you drop a perpendicular from point P from upon y-axis, this is point B, this is point C. So A is the x-coordinate of the point, OB is the y-coordinate of the point, OC is the z-coordinate of the point. So coordinates of point P are x, y, z. From this figure, it is clear that OB, the length OB is equal to this length. This is also y. And the length OC is equal to this length. This is equal to z. So coordinates of point are x, y, z. Sir, don't see clearly. Quote clearly ekipalani narjo. Which one? Which one? Suppose this is the point P. To get the coordinates of point P, we have to drop a perpendicular from point P upon xy plane, right? Then from the foot of the perpendicular, we have to draw a perpendicular upon x-axis. So OA is, if OA is x unit, OM is y unit, AM, and MP length is z unit, then the coordinates of point P are x, y, z. So x coordinate of the point is the distance of the point from yz plane. Y coordinate of the point is the distance of the point from xz plane, and z coordinate of the point is the distance of the point from xy plane. So note it down. X coordinate is equal to distance from yz plane. Y coordinate is the distance from xz plane. Z coordinate is the distance from xy plane. X coordinate is the distance of the point from yz plane, y coordinate is the distance of the point from xz plane, and z coordinate is the distance of the point from xy plane. I hope it is clear to you. Pankaj, is it clear? Pankaj, Samyajit, Nasrin, Rajlakshmi, is it clear? So guys, write down a note point, the point. Again, okay. Hmm. Suppose we have to find the coordinates of point E. This plane marked with red lines is the XY plane. This is XY plane. This plane is YZ plane marked with green lines. This is YZ plane. This is XZ plane, pink line, XZ plane, right? So the plane AB, the plane ABEF, the plane ABEF is parallel to YZ plane. The plane ABEF is parallel to YZ plane. So, x-axis is perpendicular to YZ plane. So, any plane which is parallel to YZ plane, clear, x-axis will be perpendicular to that plane. So, x-axis is perpendicular to the plane ABEF. So, if you draw a perpendicular from point P, if you draw a perpendicular from point E upon x-axis, so that will meet x-axis at the point E. Okay, this angle is 90 degree. Okay, then come to second, the plane BCD. The plane BCD is parallel to XZ plane and y-axis is perpendicular to XZ plane. So y-axis is perpendicular to BCD. If you draw any line in this plane BCD, that will be perpendicular to y-axis. So if you draw perpendicular from point E, that will meet the y-axis. So this angle is 90 degree. Okay. Similarly, if you draw perpendicular from point E upon z-axis, that will meet at the point G. Clear? This angle is also 90 degree. So this is your x coordinate, this is y coordinate, and this is z coordinate. So length OC, length OC is equal to length AB. This is x, this is y. Length OC is equal to length AB. So AB is equal to y. And the length OG is equal to length B. This is Z. Clear? So if you want to get the coordinates of a point on the space, you have to draw a perpendicular from that point upon XY plane. And from the foot of the perpendicular, we have to draw another perpendicular to x-axis. So if this is the coordinate system, let P be a point in the space. So this is OA is length x unit, AB is the length y unit, and BP is the length z unit. Then the coordinates of point P are x, y, z, right? The x coordinate of the point is the distance of the point from which plane? YZ plane. This is y. Okay. X coordinate is the distance from YZ plane. Y coordinate is the distance from XZ plane and Z coordinate is the distance from the XY plane. Is it clear now? Hello? Is it clear? Swarnajit? Okay. Then write down a note point. If the point P having coordinate XYZ lies on first bit XY plane, then Z is equal to 0. Because if a point lies in XY plane, its distance from XY plane will be 0. Hence, Z coordinate will be 0. Second, YZ plane, then X is equal coordinate of the point will be 0. XZ plane, then Y coordinate of the point will be 0. All right. This is X-axis, this is Y-axis, and this is Z-axis, right? If a point lies in XY plane, suppose P be a point in XY plane, its distance from XY plane is 0, hence its Z coordinate is 0. If the point lies on YZ plane, its distance from YZ plane is 0. Distance from YZ plane is the X coordinate. So X coordinate of the point is 0. If a point lies on X-axis, so X-axis is the intersection of two planes. X-axis is the intersection of two planes. That one of the plane is XY plane and other plane is XZ plane. If a point lies on X-axis, it lies on two planes, XY plane and XZ plane. Then you see Y coordinate and Z coordinate will be 0. Fourth point, if a point lies in X-axis, then its Y coordinate will be 0 and Z coordinate will be 0. Similarly, if lies in Y-axis, then X coordinate will be 0 and Z coordinate will be 0. Third is Z-axis, X coordinate is 0 and Y coordinate is 0. Is it clear? Write in the chat box, is it clear to you? Hello? Pankaj, Samajit, Nasrin? Okay. Then come to distance formula. That is distance between two given points. Distance between two given points. Distance between two given points. Okay. If the coordinates of two points are given, then how to calculate the distance between the points? So this is like your 2D geometry. The distance between the points B/W I'm using for between two given points. The distance between two given points Px1, y1, z1 and Qx2, y2, z2 the distance between two given points Px1, y1, z1 and Qx2, y2, z2 is given by the length PQ is equal to under root x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Okay. So this is point P, this is point Q. Then the distance PQ is equal to under root x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Then come to section formula or division formula. Section formula or division formula. Write down if R, X, Y, Z, if R be a point having coordinate X, Y, Z. Do you remember the section formula in 2D geometry? Do you remember the section formula in 2D geometry? Nasrin, Pankaj, do you remember the section formula in 2D geometry? One of the formula is internal division. Another one is external division. What is the formula for internal division in 2D geometry? Who can say? Write in the chat box what is the internal division in 2D geometry. Yes, M is to N. M is to N wala, yes. Mx2 plus nx1 upon M plus N. For internal division, x coordinate of the point is mx2 plus nx1 by M plus N. Thick. So like that, we have to write down the section formula for 3D geometry. If R, X, Y, Z be a point on the line segment if R, X, Y, Z be a point on the line segment joining Px1, y1, z1 and Qx2, y2, z2 if R, X, Y, Z be a point on the line segment joining Px1, y1, z1 and Qx2, y2, z2 such that R divides PQ in the ratio M is to N. The first bit write down internally. Second bit externally. Then the coordinates of point are given by for internal write down x is equal to mx2 plus nx1 upon m plus n, y equals to my2 plus ny1 upon m plus n, and z is equal to mz2 plus nz1 upon m plus n. This is for internal division. For external division, the formula is, this is almost same as 2D geometry. Here we are adding extra coordinate, that is z coordinate. X is equal to mx2 minus nx1 upon m minus n, y equals my2 minus ny1 upon m minus n, and z is equal to mz2 minus nz1 upon m minus n. Right? X is equal to mx2 minus nx1 by m minus n, y is equal to my2 minus ny1 by m minus n, z is equal to mz2 minus nz1 by m minus n. Just remember this formula, okay? Proof is not required. Then come to midpoint formula. Midpoint formula. Yes, Samajit A plus B by 2, right? कार ऑडियो ओपन अच्छी बैकग्राउंड नॉइज आछि मस्तिंकर ऑडियो बंद अच्छी केवल मेघाबिन मैडम कर ऑडियो ऑन अच्छी मेघाबिन मैम फिजिक्स लेक्चर आई थिंक so midpoint formula, this is point P, this is point Q, coordinates of point P are x1 y1 z1. So if R is the midpoint of PQ, it will divide the line segment in the ratio 1:1. So coordinates of R are x1 plus x2 upon 2, y1 plus y2 upon 2, z1 plus z2 upon 2. Okay. Then come to centroid of triangle. Ramajit, what is centroid? Medians of a triangle are concurrent. The point of concurrency is called the centroid of the triangle. Medians of a triangle are concurrent and the point of concurrency is called the centroid of the triangle. And the centroid divides the respective medians in the ratio 2:1. Median means the line joining the one of the vertex to the midpoint of the opposite side. Suppose this is triangle ABC. Let midpoint of side BC be D. Then AD is called a median. Let midpoint of AC be E. Then B is the another median. And CF is the another median. So medians of a triangle are concurrent, and the point of concurrence is called centroid, and generally it is denoted by G. G divides the respective medians in the ratio 2:1. Okay. Suppose coordinates of A are x1, y1, z1. Coordinates of point B are x2, y2, z2. And coordinates of point C are x3, y3, z3. Coordinates of point A are x1, y1, z1. Coordinates of point B x2, y2, z2. Coordinates of point C x3, y3, z3. So coordinates of the centroid of the triangle are x1 plus x2 plus x3 upon 3, comma y1 plus y2 plus y3 upon 3, z1 plus z2 plus z3 upon 3. Okay. Is it clear? Samyajit? Then write down direction angles. Direction angles. Angles made by line. Angles made by line with positive directions. Angles made by line with positive direction of coordinate axis. Angles made by a line with positive direction of coordinate axis are called direction angles. Are called direction angles. Angles made by a line with positive direction of coordinate axis are called direction angles. So this is your 3D system. X-axis, Y-axis, Z-axis. So there is a line like this, OP. Suppose this line makes an angle alpha with positive direction of x-axis, an angle beta with positive direction of y-axis, an angle gamma with positive direction of z-axis. Then alpha, beta, gamma are called direction angles. Alpha, beta, and gamma are called direction angles. Alpha, beta, gamma are called direction angles. Just a minute, guys. Then write down direction cosines. direction cosines or DCS. Cosine of the angles made by line cosine of the angles made by a line with positive direction of coordinate axis are called direction cosines. And these are generally denoted by LMN. Okay. X-axis, Y-axis, Z-axis. Suppose OP is a line which makes an angle alpha with positive direction of x-axis and angle beta with positive direction of y-axis and an angle gamma with positive direction of z-axis. So alpha, beta, gamma are called direction angles. Cos alpha, cos beta, and cos gamma are called direction cosines. These are denoted by LMN. L is the cos alpha, M is cos beta, and N is cos gamma. And you know the maximum value of cosine function is 1 and minimum value is -1. So the value of L lies between -1 and 1. Value of M lies between -1 and 1. And value of N lies between -1 and 1. Right? Alpha, beta, gamma are called direction cosines. So the direction angles, LMN are called direction cosines. Clear? बुझी पारलो कि नहीं चार्ट बॉक्स रे लेख पिले बुझीला पंकज सौम्यजीत नसरीन and a very important note point. OP is a line. Suppose length of OP is equal to R and the direction cosines of the line OP are LMN. Then the coordinates of point P will be LR, MR, NR. If length of OP is equal to R, DCS of OP are LMN, then the coordinates of point P are LR, MR, NR. Come to the explanation. For convenience, Consider this one as your x-axis, this one as y-axis, and this one as z-axis, right? So OP is a line having length r and a DCS LMN. So let this angle is alpha. Draw a perpendicular from point P upon x-axis. Let M be the foot of the perpendicular. Then suppose OM length is x, OP length is given, that is r. So in the triangle OPM, this is right angle triangle. The value of cos alpha is equal to, suppose coordinates of point P are x, y, z, right? So cos alpha is equal to x by r. Similarly, cos beta is equal will be y by r, and cos gamma is equal to z by r. Cos alpha is denoted by L, cos beta is denoted by M, and cos gamma is denoted by N. So L is equal to x by r, M is equal to y by r, N is equal to z by r. So x is equal to L by r. This implies x is equal to LR, y is equal to MR, and z is equal to NR. So x is equal to LR, y is equal to MR, and z is equal to NR. So the coordinates of point P are LR, MR, NR. Rajlakshmi, is it clear? Samajit? Okay. Then next note point, if LMN be the DCS of a line, if LMN be the DCS of a line, then L square plus M square plus N square is equal to 1. If LMN the DCS of a line, then L square plus M square plus N square is equal to 1. Come to the proof. Let OP be a line. Suppose length of OP is equal to R. Let DCS of OP be LMN. Then the coordinates of point P are LR, MR, NR. What are the coordinates of origin? Coordinates of origin are 0, 0, 0. OP length is equal to R. This implies OP square is equal to R square. Now we can calculate OP by using distance formula. So OP square will be LR minus 0 whole square, x2 minus x1 whole square plus y2 minus y1 whole square, MR minus 0 whole square plus NR minus 0 whole square is equal to R square. This implies L square R square plus M square R square plus N square R square is equal to R square. Now you can take R square as common from the left hand side. So R square whole into L square plus M square plus N square is equal to R square. R square cancels. This implies L square plus M square plus N square is equal to 1. This is very, very important. You have to remember this. What is L? L is equal to cos alpha, M is equal to cos beta, N is equal to cos gamma. If alpha, beta, gamma be the direction angles of a line, then you can write cos square alpha plus cos square beta plus cos square gamma is equal to 1. Cos square alpha plus cos square beta plus cos square gamma is equal to 1. Right? Now come to discuss couple of rudimentary questions. Question number 1. Find the DCS of coordinate axis. Find the DCS of coordinate axis. This is the first question. Question number 2. Find the DCS of a line find the DCS of a line equally inclined find the DCS of a line equally inclined with coordinate axis. Find the DCS of a line equally inclined with coordinate axis. Question number 3.
तेरा प्यार 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 हुक्का बार, तेरा प्यार 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 हुक्का बार बार बार, ओ बाबरिया. हेलो सर, गुड मॉर्निंग. हेलो सर, हवा पानी कैसी है आपका? हेलो सर, आपकी शादी हो गई क्या? हेलो सर, कुंवारे लग रहे हो. हेलो
If a line makes an angle 60 degree with x-axis, 45 degree with y-axis, Then find the angle made by it with Z axis. Okay. So these are the three simple questions. So guys, answer these questions sent to me through chat box. I hope you can solve these questions. Tell me the answer. Samnajit, Nasrin, Pankaj, Rajlakshmi. Going to discuss the question number 1. This is x-axis. This is y-axis. This is z-axis. I think the first answer has come. Okay. X-axis makes an angle 0 degree to x-axis, 90 degree with y-axis, and 90 degree with z-axis. So direction cosines of the x-axis will be cos 0, cos 90, cos 90, cos 0, cos 90, cos 90. Cos 0 is 1, cos 90 is 0, cos 90 is 1, 0, 0. Is the DCS of x-axis. Similarly, the DCS of y-axis will be 0, 1, 0. And the DCS of z-axis is 0, 0, 1. Is it clear? Did you understand, guys? Is it clear? 60 degree, not 120 degree. This is 60 degree. Okay. Then come to question number 2. The question is find the direction cosines of a line equally inclined with coordinate axis. We have to find the DCS of line equal inclined with coordinate axis. So equal inclined means make same angle with coordinate axis. Suppose that line makes an angle alpha with x-axis, same angle, beta with y-axis, and angle alpha with z-axis. Suppose the line makes angles alpha, alpha, alpha with coordinate axis. Then you see DCS will be cos alpha, cos alpha, cos alpha. Okay. This is L, this is M, this is N. If LMN be the DCS of line, then L square plus M square plus N square is equal to 1. L square plus m square plus n square is equal to 1. This implies cos square alpha plus cos square alpha plus cos square alpha is equal to 1. This implies 3 cos square alpha is equal to 1. Cos square alpha is equal to 1 by 3. Cos alpha is equal to 1 by root 3 or minus 1 by root 3. So DCS of the line will be 1 by root 3, 1 by root 3, 1 by root 3 or minus 1 by root 3, minus 1 by root 3, minus 1 by root 3. Clear? I hope it is clear to you. Then in the same line of thinking, you can answer the question number 3. Try to answer the question number 3. Try to solve question number 3 and send me the answer. The question number 3 is a line makes an angle 60 degree with x-axis and 45 degree with y-axis. Then we have to find out the angle made by it with the z-axis. Let alpha be the angle. Let alpha be the angle made by the line with coordinate axis. Okay. Then cos 60, cos 45, and cos alpha are direction cosines of the line. Cos 60, the value of cos 60 degrees is 1 by 2, cos 45 degrees 1 by root 2, and cos alpha are direction cosines. This is L, this is M, this is N. If element be the DCS of line, then L square plus M square plus N square, L square plus M square plus N square is equal to 1. This implies 1 by 2 whole square plus 1 by root 2 whole square plus cos square alpha is equal to 1. This implies 1 by 4 plus 1 by 2 plus cos square alpha is equal to 1. 1 by 4 plus 1 by 2 is 3 by 4. So cos square alpha is equal to 1 minus 3 by 4. This is equal to 1 by 4. Cos alpha is equal to 1 by 2. This implies alpha is equal to 60 degree. Okay. Okay. Then come to direction ratios. Did you understand, guys? Write in the chat box. Is it clear to you? Pankaj, Samajit? Direction ratios. Known as DRS. Direction cosine short form DCS. Direction ratio short form DRS. The real number tried ABC those are proportional the real number tried ABC those are proportional the real number tried ABC those are proportional to the direction cosines of a line are called direction ratios. Direction cosines of a line. The real number tried ABC, those are proportional to the direction cosines of a line are called direction ratios. If LMN be the DCS of a line, that means these are three real numbers. Each of them rise between -1 and 1. If we choose three real numbers ABC, such as A upon L is equal to B upon M is equal to C upon N, then ABC are called direction cosines. So we, in the previous problem, got the direction cosines of a line are 1 by root 3, 1 by root 3, 1 by root 3. So 2 by root 3, 2 by root 3, 2 by root 3 are proportional to the direction cosines. 5 by root 3, 5 by root 3, 5 by root 3 are proportional to 1 by root 3, 1 by root 3, 1 by root 3. So these are called the DRS of the line. These are also called the DRS of the line. Okay. So if you take the proportionality constant as K, then will be equal to KL, where K is a non-zero constant, B is equal to Km, and C is equal to Kn. So any non-zero constant multiple of direction cosines of a line are called the direction ratios. Any non-zero constant multiple of direction cosines of a line are called the direction ratios. Okay. So guys, your first session is over. So second session I'll start exactly at 9:15. Okay. And that session will be very, very important for 3D geometry. All the important formulas will be discussed in the second session, right? Samyajit, Nasirin, try to attend the second session today. Okay. Present. Okay. Guys, come to discuss couple of key points. DCS of line are unique, but DRS are many. Point number 2, if A1, B1, C1 and A2, B2, C2 are two sets of then A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. Third point, if element be the DCS of line, then we can write L upon L is equal to M upon M is equal to N upon N, which implies that this implies DCS of a line can be considered DCS of a line can be considered as its DRS, but the converse is not necessarily true. But the converse is not necessarily true. Okay, then the fourth point is if ABC is the DRS of a line, if ABC be the DRS of a line such that A square plus B square plus C square is equal to 1, then ABC are the DCS of the line. Okay, quickly note it down. Rajlakshmi, is it clear? Then come to projection. First come to projection of a point on a line. Suppose this is line L. There is a point P. if we want to get the projection of point P on line L, draw a perpendicular from point P upon L, the foot of the perpendicular, let it be M. M is equal to projection of point P on line L. M is the projection of point P on L. Okay. Then projection of a line segment on a line. Let PQ be a line segment and L be a line. If you want to get the projection, then projection means the portion covered by the shadow of the line segment on the line. So for that, we have to draw two perpendiculars, PM and QN. Okay. So MN is the projection of PQ. MN is the projection of PQ. On L. MN is the projection of PQ on L. Right? MN is the projection of PQ on line L. Now extend the line PQ. Okay, suppose the line segment makes an angle theta with the line L. Now draw a perpendicular from point P upon QN. Let R be the foot of the perpendicular. Then angle QPR is equal to theta. So PQR is a right angle triangle. In the triangle PQR, cos theta is equal to PR by PQ. So PR is equal to PQ cos theta. What is PR? PR is equal to MN. That is projection of PQ on line L is equal to PQ cos theta. This is equal to projection of a line segment on a line is equal to length of the line segment. Projection of a line segment on a line is equal to length of the line segment into cosine of the angle between the line and the line segment. Projection of a line segment on a line is equal to length of the line segment into cosine of the angle between the line and the line segment. Okay. Another formula is also there to find the projection of a line segment on a line segment. If the coordinates of endpoints of the line segment are given and direction cosines of the line L are given, then you can calculate the projection. So let's quickly note it down. I'll go to the next page. Rajalakshmi, is it clear? Sujain? Suppose there is a line segment PQ. Let the coordinates of point P be x1, y1, z1, and coordinates of point Q be x2, y2, z2, and L be a line having direction cosines LMN. Okay. So projection of PQ on line L. Let the foot of the perpendiculars be M and N. So Mn is the projection. So length Mn is equal to x2 minus x1 into L plus y2 minus y1 into M plus z2 minus z1 into N. x2 minus x1 into L plus y2 minus y1 into M plus z2 minus z1 into N. You just remember this formula. I will prove it whenever I will take your class on vector. So projection of a vector on another vector, projection of a vector A on vector B is equal to A dot B by B mod. Okay. So come to a note point. If Px, Py and Pz be the length of projections, if Px, Py and Pz be the length of projections of a line segment on coordinate axis on x, y and the z axis. Respectively, then the length of the line segment is under root Px square plus Py square plus Pz square, and the direction cosines of line segment are Px by under root Px square plus Py square plus Pz square, comma, Py by under root Px square plus Py square plus Pz square, Pz by under root Px square plus Py square plus Pz square. To come to the explanation, for the sake of convenience, consider this one as the x-axis. This one is the y-axis, and this one is the z-axis. There is a line segment PQ whose projection on x-axis, length of the projection on x-axis is denoted by Px. This length is Px. Suppose the line makes an angle alpha with x-axis and draw a perpendicular from point P upon QN, this is M, this is N. Let R be the foot of the perpendicular. The length Mn is equal to length PR. Length PR is equal to Px. This angle is also alpha. In the triangle PQR, the triangle PQR, cos alpha is equal to Px upon PQ. Cos beta is equal to Py upon PQ. And cos gamma is equal to Pz upon PQ. Cos alpha is equal to Px upon PQ. Cos beta is equal to Py upon PQ. And cos gamma is equal to Pz upon PQ. We have cos square alpha plus cos square beta plus cos square gamma is equal to 1. Cos alpha, cos beta, cos gamma are called the direction cosines. Cos square alpha plus cos square beta plus cos square gamma is equal to 1. If LMN be the DCS of line, then L square plus M square plus N square is equal to 1. So this implies Px upon PQ whole square plus Py upon PQ whole square plus Pz upon PQ whole square is equal to 1. So after simplification, this implies Px square plus Py square plus Pz square is equal to PQ whole square. What is PQ? PQ is the length of the line segment. PQ is the length of the line segment. So PQ is equal to under root Px square plus Py square plus Pz square. Cos alpha is Px by PQ. Cos alpha, cos beta, cos gamma are direction cosines. Cos alpha, cos beta, cos gamma are direction cosines. So Px upon under root sigma Px square. Sigma Px square means Px square plus Py square plus Pz square. Py upon under root sigma Py square and Pz upon under root sigma Pz square. Right? I hope it is clear to you. So guys, let me know, is it clear? MPC Daripada, Padampur, Rajlakshmi, is it clear? Sujain? Then come to angle between two lines. Angle between two lines. The angle theta between two lines, the angle theta between two lines, the angle theta between two lines, whose DCS are L1, M1, N1 and L2, M2, N2 is given by the angle theta between two lines whose DCS are L1, M1, N1 and L2, M2, N2 is given by theta is equal to cos inverse L1, L2 plus M1, M2 plus N1, N2 theta is equal to cos inverse L1, L2 plus M1, M2 plus N1, N2. If instead of BCS of line DRS are given, then you can calculate, write down the angle theta between two lines whose DRS are given by A1, B1, C1 and A2, B2, C2 each theta equals to cosine inverse A1, A2 plus B1, B2 plus C1, C2 upon under root A1 square plus B1 square plus C1 square into under root A2 square plus B2 square plus C2 square. Just make a note, I will explain it. Okay. Explanation. Right, this is our x-axis, this is y-axis, and this is z-axis. We have to find the angle between two lines. So P is a line, OQ is another line. Okay. So DCS of OP is given and the DCS of OQ are given. We have to find the angle between these two lines. Or DCS of OP are L1, M1, N1, and the DCS of OQ are L2, M2, N2, right? We have to find out this angle theta. Let the length OP is equal to R. Already I have told you, this is system. If OP be a line having length R and the DCS element If OP be a line having length R and a DCS LMN, then the coordinates of point P are LR, MR, NR. Coordinates of point P are LR, MR, NR. So since DCS of OP are L1, M1, NR, and length of OP is R, then the coordinates of point P are L1R, M1R, N1R, right? And the coordinates of origin 0, 0, 0. Now we have to find the projection of OP. This is 90 degree on OQ. The projection is x2 minus x1 into L plus y2 minus y1 into M plus n z2 minus z1 into N. So OM, length OM is equal to L1R minus 0 into L2 plus M1R minus 0 into M2 plus N1R minus 0 into N2, right? Again, another formula is also there to find the projection. Projection of a line segment on a line is equal to length of the line segment into cosine of the angle between the line and line segment. So M is equal to length of the line segment we have considered as R and cosine of the angle R cos theta. Okay. So R cos theta is equal to L1 into L2R plus M1 into M2R plus N1 into N2R. Now we can take R as common from each term of the right hand side. This is equal to L1 L2 plus M1 M2 plus N1 N2 into R. Here R cancels. So cos theta is equal to L1 L2 plus M1 M2 plus N1 N2. This implies theta is equal to cos inverse L1 L2 plus M1 M2 plus N1 N2. Theta is equal to cos inverse L1 L2 plus M1 M2 plus N1 N2. I hope it is clear to you. If DRS of the line are given, if DRS of the one line is A1, B1, C1, then from DRS we can find its DCS. So DCS will be A1 upon under root A1 square plus B1 square plus C1 square, A2 upon B1 upon under root A1 square plus B1 square plus C1 square, and C1 upon under root A1 square plus B1 square plus C1 square. Right? Then come to special cases. Theta is equal to 0 degree. That is lines are parallel lines. Theta is equal to 0 degree, lines are parallel lines. That is L1 is equal to L2, M1 is equal to M2, N1 is equal to M2. Lines are parallel. If L1 is equal to L2, M1 is equal to M2, and N1 is equal to L2. In terms of DRS, if DRS of two lines are given, suppose DRS of one of the line are A1, B1, C1, DRS of the second line are A2, B2, C2, and if these two lines are parallel, then A1 upon A2 equals to B1 upon B2 is equal to C1 upon C2. This is the condition for parallelism of two lines. Okay. Then come to case 2. Lines are perpendicular lines. Two lines are perpendicular. हाँ, हेलो। हम्म, नमस्कार। ଡାକ୍ତର ଉପରକୁ ବାହାରିବା ଆଉ। ମୁଁ ଘରକୁ ଖାଇକି ଯିବି ଦେଖିବା। ମୁଁ କ୍ଲାସରେ ଅଛି, କ୍ଲାସ ସାରିକି କଲ୍ କରୁଛି। କ୍ଲାସରେ ଅଛି, କ୍ଲାସ ସାରିକି କଲ୍ କରୁଛି। ମୁଁ ଗଭର୍ଣ୍ଣମେଣ୍ଟ କ୍ଲାସରୁମରେ ଅଛି। ହ୍ୟାଲୋ, ହ୍ୟାଲୋ। Then come to case 2. Theta is equal to 90 degree. Theta is equal to 90 degree. That is, lines are perpendicular. Lines are perpendicular. Just a minute, guys. Case 2, lines are perpendicular lines. Lines are perpendicular lines. Theta is equal to 90 degree. So L1 into L2 cos theta is equal to L1 L2 plus M1 M2 plus N1 N2. Cos theta is equal to L1 L2 plus M1 M2 plus N1 N2. Since theta is equal to 90 degree, cos 90 will be 0. 0 is equal to L1 L2 plus M1 M2 plus N1 N2. Two lines are perpendicular. If and only if L1 L2 plus M1 N2 plus N1 N is equal to 0. In terms of DRS, the lines are perpendicular. In terms of DRS, the lines are perpendicular. If lines are perpendicular, if and only if A1 upon A2, sorry, A1 into A2 plus B1 into B2 plus C1 into C2 is equal to 0. A1 into A2 plus B1 into B2 plus C1 into C2 is equal to 0. This is the condition for perpendicularity of two lines. Two lines are perpendicular if L1 L2 plus M1 M2 plus N1 N2 is equal to 0, or A1 A2 plus B1 B2 plus C1 C2 is equal to 0. I hope it is clear to you. So guys, write in the chat box, is it clear? Now we'll discuss couple of questions based on these concepts. That's the angle between two lines. Sujain, Rajalakshmi, is it clear? Write in the chat box. Hello. Okay. Rajalakshmi, you are from which higher secondary school? Are you aspiring for JEE or NEET? Rajalakshmi? Katak College. Okay. Let's done the first question. Question number 1. Find the angle. Sorry. So that the angle between So that the angle between two main diagonals, so that the angle between two main diagonals so that the angle between two main diagonals of a cube is cos inverse 1/3. So that the angle between two main diagonals of a cube is cos inverse 1/3. Come to the solution. This is a cube. Sides are of equal length. Let the vertices be O, A, B, C, D, E, F, G. Right? Two main diagonals means two body diagonals. Okay. That means O is a body diagonal. OE is a body diagonal and BG is another body diagonal. We have to find the angle so that the angle between these two is cos inverse 1/3. Sides are of equal length. Let the length of the side be a unit. If the length of side is a unit, then coordinates of point A are A 0 0. Coordinates of point B A 0. Coordinates of point C, point E A. Coordinates of point E are A. Coordinates of point C lies on x-axis. Consider this one as x-axis. This one as y-axis. And this one as z-axis, right? So C lies on y-axis. Its coordinates are 0, A, 0. Coordinates of D are 0, A. Coordinates of G, 0, 0, A. Right? You have to find the angle between OE and BG. Coordinates of O, that is the origin of the system, are 0, 0, 0. So DRS of OE are A, x2 minus x1, y2 minus y1, z2 minus z1. If PQ be a line segment having coordinates of point P are x1, y1, z1, coordinates of Q are x2, y2, z2, then DRS of PQ are x2 minus x1, y2 minus y1, and z2 minus z1. DRS of PQ are x2 minus x1, y2 minus z1, z2 minus z1. Similarly, so using the same formula, DRS of OE are A minus 0, A minus 0, A minus 0, that is A. DRS of BG are A minus 0, that is A minus 0, A minus 0, A minus 0, 0 minus A. So A minus A. Clear? This is A1, B1, C1, A2, B2, C2. The angle theta is given by theta is equal to cos inverse A1, A2 plus B1, B2 plus C1, C2. A1, A2 will be a square, B1, B2 will be a square, C1, C2 is minus a square divided by under root A1 square plus B1 square plus C1 square. That is under root A square plus A square plus A square into under root a square plus a square plus a square. Okay. Theta is equal to cos inverse A1 A2 plus B1 B2 plus C1 C2. Government class call করছে. Right? This is equal to cos inverse plus a square minus square cancels a square upon. This is equal to 3a square root over the root 3a into 3a square root over the root 3a. So a into a square cancels. Root 3 into root 3 is root 3. This is equal to cos inverse 1 by 3. I hope it is clear. Did you understand? Write in the chat box. Rajlakshmi, MPC, Sukudi, SS. Is it clear? Next, question number 2. If LMN and L plus delta L, M plus delta M, N plus delta N, if LMN and L plus delta L, M plus delta M, N plus delta N with the DCS of a line in two neighboring positions, and delta theta be the small angle included between them, and the delta theta be the small angle included between them, then so that delta theta whole square equals delta L whole square plus delta M whole square plus delta N whole square. Delta theta whole square is equal to delta L whole square plus delta N whole square plus delta N whole square. This angle is delta theta, very, very small angle. LMN with the DCS of line and L plus delta L, M plus delta M, and N plus delta N is the DCS of the line in two neighboring positions, right? Since LMN are the DCS of the line, then L square plus M square plus N square is equal to 1. Again, L plus delta L, M plus delta M, N plus delta N, DCS of the another line. So L plus delta L whole square plus M plus delta M whole square plus N plus delta N whole square is equal to 1. This implies L square plus delta L square plus 2L delta L plus M square plus delta M whole square plus 2M delta M plus N square plus delta N whole square plus 2N delta N is equal to 1. L square plus M square plus N square is equal to 1. So L square plus M square plus N square is equal to 1 cancels. So delta L square, this implies delta L square plus delta M square plus delta N square plus twice of L into delta L plus M into delta M plus N into delta N is equal to 0. All right? So delta L square plus delta N square plus delta N square is equal to minus of twice of L into delta L plus M into delta N plus N into delta N minus of twice of L into delta L plus M into delta N plus N into delta N. This is the question, right? So we have to show that delta L square plus delta N square plus delta N square is equal to delta theta square. What is delta theta? Delta theta is the angle between two lines, right? So cos, cosine of the angle between two lines, cos delta theta is equal to L into L plus delta L plus M into M plus delta M plus N into N plus delta N. Cos delta theta is equal to L into L plus delta L, M into M plus delta N, N into N plus delta N. So this implies cos delta theta is equal to L square plus L into delta L plus M square plus M into delta M plus N square plus N into delta N. This is equal to L square plus M square plus N square plus L into delta L plus M into delta M plus N into delta N. Right? L square plus M square plus N square is equal to 1. This is equation 1. Huh? So L into delta L plus M into delta N plus N into delta N is equal to cos delta theta minus of L square plus M square plus N square. L square plus M square plus N square is equal to 1. This is equation 2. Now substitute the value of L plus delta L, L plus delta L. Now substitute the value of L plus delta L, M plus delta N, N plus delta N in equation 1. quickly note it down. I will use the next page. Just a minute. Now substitute the value of L into delta L, M into delta M, N into delta N in equation 1. So guys, I'm using the next page. Thus, delta L whole square plus delta M whole square plus delta N whole square is equal to -2 into L into delta L, M into delta M, N into delta N, which is equal to cos delta theta -1. So this is equal to 2 into 1 minus cos delta theta. You know, formula for lowering integering trigonometry, 1 minus cos theta is equal to twice of sine square theta by 2. 1 minus cos theta is equal to twice of sine square theta by 2. This is equal to 2 into 2 sine square delta theta by 2. This is equal to 4 sine square delta theta by 2. So guys, you know, if theta is very, very small, if theta is very, very small, that is, if theta tending towards 0, then sine theta is equal to theta. Okay. If theta is very, very small, then sine theta is equal to theta. So here delta theta is very, very small angle. So sine delta theta by 2 is equal to delta theta by 2. Sine delta theta by 2 is equal to delta theta by 2. This is equal to 4 into, so sine square delta theta by 2 will be delta theta by 2 whole square. This is equal to 4 into delta theta whole square divided by 4. 4 cancels. So delta L square plus delta n square plus delta n square is equal to 1. Delta L square plus delta n square plus delta L square is equal to 1. I hope it is clear. Quickly note it down, then we will proceed to next question. Okay. Write down the next question. If element next question, so that the DCS of a line which is perpendicular so that DCS of a line which is perpendicular to to two mutually perpendicular lines whose DCS are L1, M1, N1 and L2, M2, N2 are M1, N2 minus M2, N1, N1, L2 minus N2, L1, L1, M2 minus M2, N1. Okay, this is the question. First note the question, then I will explain it. So that the DCS of a line which is perpendicular to two mutually perpendicular lines, whose DCS are L1, M1, N1, and L2, M2, N2 are M1, M2 minus M2, N1, N1, L2 minus L2, L1, L1, M2 minus M2, N1, right? That means these three lines are mutually perpendicular. This is suppose line L1, this is line L2, and this is line L. So DCS of L1 line are L1, M1, N1. DCS of L2 line are L2, M2, N2. We have to show that DCS of this line, line L, DCS of the line L are M1, N2 minus M2, N1, N1, L2 minus M2, L1, L1, M2 minus, sorry, this is wrong. M1, N2 minus N2, N1. Okay. Oh, right. So let us consider, assume that let element be the DCS of the required line. Okay. Since these two lines are perpendicular, L1 and L2 are perpendicular. So L1, L2 plus M1, M2 plus N1, N2 is equal to 0. L1, L2 plus M1, M2 plus N1, N2 is equal to 0. Line L is perpendicular to L1. So LL1 plus MM1 plus NN1 is equal to 0. And the line L is also perpendicular to L2. So LL2 plus MM2 plus NN2 is equal to 0. Okay. This is equation 1. This is equation 2. And this is equation 3. Okay. So solving equation 2 and 3 simultaneously by cross multiplication. Solving equation 2 and 3 by cross multiplication. Solving equation 2 and 3 by cross multiplication. We will get L upon M1 N2 minus N2 N1 M upon N1 L2 minus N2 L1. So I think just a minute. N upon L1 M2 minus L2 M1. So we have assumed LMN are the DCS of the line. The real number triad, those are proportional to direction cosines of a line, are called the direction ratios. So direction ratios are the DRS of line LR. This implies DRS of line L are M1 N2 minus M2 N1, N1 L2 minus N2 L1, L1 M2 minus L2 M1. These are the DRS. But the question is, we have to show that these three quantities are DCS of the line. Already I have told you, if ABC are the DRS of line, such that A square plus B square plus C square is equal to 1. If ABC be the DRS of a line such that A square plus B square plus C square is equal to 1, then you can say that ABC are DCS of the line. So these are the DRS of line. If the square of all these three quantities, sum of the square of all these three quantities equal to 1, then you can say that these three quantities are the DCS of the line. Now take the square of all these three quantities. M1, N2 minus M2, N1 whole square plus N1, L2 minus N2, L1 whole square plus L1, M2 minus L2, M1 whole square. Okay. So guys, quickly note it down. I will use the next page. Who all are the participants? Vicky, MPC, Najo, Realme, Rajlakshmi. Okay. So M1, N2 minus M2, N1 whole square plus N1, L2 minus N2, L1 whole square plus L1, M2 minus L2, M1 whole square. This is equal to M1, N2 whole square plus M2, N1 whole square, A square plus B square minus 2AB minus 2 M1, M2, N1, N2 plus L1, N1, L2 whole square plus N2, L1 whole square minus 2 L1, L2, N1, N2 plus L1, M2 whole square plus L2, M1 whole square minus 2 L1, L2, M1, M2. Right? This total expression can be simplified as L1 square plus M1 square plus N1 square. L1 square plus M1 square plus N1 square into L2 square plus M2 square plus N2 square. L1 square, M1 square, N1 square into L2 square plus M2 square plus N2 square minus L1, L2 plus M1, M2 plus N1, N2 whole square. Okay. So L1 square plus M1 square plus N1 square is equal to 1. L2 square plus M2 square plus N2 square is equal to 1. L1, L2 plus M1, M2 plus N1, N2 is equal to 0. So this value is equal to 1 into 1 minus of 0, which is equal to 1. So we find that sum of the squares of these three quantities, sum of the squares of these three quantities equal to 1. Thus, DCS of the required line, DCS of the required line are M1, N2 minus M2, N1, N1, L2 minus N2 L1, L1 M2 minus L2 M1. I hope it is clear to you. Guys, write in the chat box, is it clear? Rajalakshmi, is it clear? MPC Baripada. Okay, quickly note it down. Okay. Homework question for you. So that the DCS of internal angle bisector, the DCS of internal angle bisector of the angle between two lines so that the internal bisector of the angle so that the internal bisector of the angle between the lines whose direction cosines are given by L1, M1, N1 and L2, M2, N2 are L1 plus L2 divided by 2 cos theta by 2, M1 plus M2 divided by 2 cos theta by 2, N1 plus N2 divided by 2 cos theta by 2. L1 plus L2 by 2 cos theta by 2, M1 plus M2 by 2 cos theta by 2, N1 plus N2 by 2 cos theta by 2. This is question number 1. This is homework for you. Question number 2. If a line makes angles alpha, beta, gamma, delta with 4 diagonals of a cube, then show that cos square alpha plus cos square beta plus cos square gamma plus cos square delta. Cos square alpha plus cos square beta plus cos square gamma plus cos square delta is equal to 4 upon 3. So these are the 2 questions. Homework for you. So guys, in the next class we will discuss the answer to these 2 questions if you are unable to solve. Okay. So guys, today's class is over. We'll meet in your next schedule. Vicky, Vishwajit Vicky. Is it clear?